Good evening, everyone. Am I audible? And I have shared my screen. Kindly acknowledge if my screen is visible.
Yeah, good evening, ma'am. It's with you.
All right, great. Okay. So in this session, we'll be discussing the overview of week 5 to 8. Okay. So in week 5, it consists of the list, right? So do you all remember like what is the list and all?
Yes, ma'am. A sequence of elements.
Yes, exactly. Let's say I have to store the set of values like, uh, let's take a data set of a student. So what are all there? So it will consist of a name, and then it consists of a DOB, and then which city they belong to. Then it contains their physics, maths, chemistry marks, as well as the total. So you can give all these things in a particular row. I mean, like in a particular list. Let's say a person, we have a serial number, sequence number also, right? Let me
Yes.
give it as a sequence number. Yeah. So there will be a sequence number, and then we can give their name, and then we can just give their DOB or the total mark, whatever it is. You can add all these things into a list, or you can just add a particular set of elements also. So this is what we'll try to do it in a list. So list is used to store the set of elements of a particular person or particular subject or whatever it is. Okay. Is this thing clear, people?
Yes, ma'am.
So similarly, there is a pseudo code for creating a like how to insert the elements in the listing. Okay, let me just yeah. So this is how we'll just give it. So first, we have to give the sequence number, and then we can just give the elements. Like let's say these are the sequence number, and these are the values inside. Or you can just create a empty list also. So these are the way. Like generally, we'll just use the square braces for it, and inside square braces, you can give whatever the value is. If it is an integer, you can just give it straight away. If it is a string, we'll give it in a quotes. So within the quotes, the values will be there. Is that clear?
Yes, ma'am.
Yeah. So this is how we'll just give the values of it. And similarly, if I have to add to list, we have to use a double plus, that is plus plus. By this way, I can be able to append to list, which means, so here I have two elements and here I have three elements. I have to combine it together into a single list, which contains of a five elements like this. Okay, so this can be done by using appending a list, that is by plus plus. If I use a plus plus in a list, which means we have to append it. Is that clear, people?
Yes, ma'am.
And then here you can see that they have just created an empty list initially, and then we are just checking the whatever the rows are there in a table, and we are trying to add the elements in that. That is, if the let's say I'm taking a card. In the particular card, if the month of the birth is May, then I have to add it into this list. Whatever is the sequence number, I have to add it as a list to it. Okay, which means let's say the sequence number 5 containing the birth as month. So, birth month as May. So I'll add 5 initially. And then let's say we have a number 6 or 12. So I have to add 12 into the May list. And then we'll try to add the 17. So this is how we'll try to add it into the May list. Okay, so I have to give the name of that list, and then we have to give in the braces what value to be added. Is that clear?
Yes, ma'am.
Yes. Great. So this is a similar way. Here they have used the city, like town city has to be equal to Chennai, then add it. So by this way, you can just give whatever the condition and whatever the values to be added. And then you can just check the values also. If in both the same similarities are there. Let's say the person born in May and the same person is in the Chennai. So only those values would be added here. I mean, those sequence numbers are added. Okay. Is that clear, people?
Yes, ma'am.
Okay. Similarly, if I have to find the top three students, which means like top three marks of a let's say that we have three subjects, right? Let's say the subject is maths, physics, and chemistry. Let me take a chemistry mark. So in the particular subject, I'll check which is the maximum, first maximum, second maximum, and third maximum of a particular subject. We can do it for all the three subjects by calling the same function again. I mean, the same procedure again and again also. So, you can just go through this and tell me what are we doing in this? Like what this if condition is doing and what this if does and what this if is doing actually.
It is finding the maximum subject marks.
Yes. So actually what this method, like what this if condition meaning, like what it is doing actually.
If the subject marks are more than the maximum, which is initially it is zero, in that
Hmm.
case, it is trying to shift this subject marks to the maxima, and then maximum to the second maximum, and second maximum to the third maximum.
Yes. So let's say the first maximum mark which we are getting is, let's say first subject, we are taking a first sequence number. In that the mark is 56. So what will happen now? What is the maximum initially?
Zero,
It is 0. How about the second max?
also zero,
Yeah. And how about the third max?
also zero.
Yeah. So what it will do is it will just check what is the subject mark which we have got is 56. So here in this condition, it will check whether the 56 is greater than the 0. So if 56 is greater than 0, what will happen? Of course, the condition is true. So what is the third max? So whatever is the second max now?
Second max zero,
Yeah, that will be stored in the third max. And whatever is the max value so far?
56.
No, 0, right? We haven't updated it yet.
Right, 56.
So it is still 0. So now the second maximum is 0. And what is the maximum mark?
Max 56.
Now it's
Yeah. Yeah, now the maximum mark is updated with the mark of 56. Okay, so here it is updated as 0 and here we'll get it as 56. And what will happen to this condition? Will this condition be checked?
no, this would return false, right?
Yeah, because what is the maximum mark now?
Now it's 56.
56.
Yeah, 56
Yes,
is
it will check. Is 56 is greater than 56?
no, it's equal to 56. So it's
Yeah,
this.
so the condition failed. So the uncondition, will it check the next condition?
No, no.
No.
Actually, no.
There's a,
Because
because
it's an AND, right?
anything.
Yes, actually what it does is like if one condition failed in AND, it is going to give false only. So no need to check the second condition at all. So how about this if people?
No, it's also return false.
Yeah, because what is the second maximum so far?
It's 0, right?
Yes, is 0 is greater than the 56?
No.
Of course, it's not going to be, and the condition is given, so this is not going to be checked at all. Okay, so now the value, that is the 56, that card has to be moved to the table 2. We have given a card number 1 from table 1. Now what I have to do, using the while, we'll try to take the second card. Again, we'll do the same process, right? Let's say the next card containing 43. Then,
Then 43 is less than max. So it's not updated. The first condition is not updated.
yes, because the maximum is not going to be updated because it's like
Yeah.
43 is not greater than the 56. Condition failed. So
But
how about this?
second condition is going to get updated.
Yeah, because After 56, this is the maximum, like second maximum as of now. So what will happen? Here we have 56 is greater than 43. Yes, the condition is true. So it has to come to this step. What is the subject mark? It's 43. What is the previous second max?
0.
Yes. What is the third max?
0.
Till 0.
Yes, third max is also 0. So now what it has to do, it will check. Is 43 is greater than 0?
Yes.
Yes, the condition is true. So the third max is still 0, but second max is updated with the mark 43. Is it clear?
Yes, ma'am.
Okay, so how about this if condition, people?
It doesn't check for it.
Why so?
Yeah, because of the equality, because now X subject is 43.
Yes, is 0. So far, we have updated the second max is to 43. So is 43 is greater than 43?
No, it should be
No,
an
condition
equality.
failed. Yes, if it is equal, then it's fine. So this condition will not work. So third maximum is not updated yet. Okay, let's say the next thing which I'm getting is of 82. Now what will happen?
Okay, so now the max will get updated, and second max
Yes.
will update it to be the last max, and then third max to the second max.
Yes, all the values will be like keep going. This will move to the second maximum, and second maximum will move to the third maximum in such a way that x dot subject is what? As of now, it's 82. Is 82 is greater than 56?
Yes.
Yes. So what has to be the third maximum?
43.
Yes, whatever is the second maximum previously, that has to be the third maximum now. What is the next line given?
Max 56 will become second max.
Yes, whatever is the max value, that has to be the second maximum now. So 56 and 56. And what about this line? Max is equal to the current subject mark, which is nothing but 82. Is it clear? So how
Yes, ma'am.
about these conditions? Will this condition be checked? Yes, people, will this condition be checked?
Yes, this condition will be checked.
Actually, this condition is failed, right? Because maximum is 82. Current subject is also 82. So 82 is not going to be greater than 82. So this is not going to work. How about this?
I understand, but condition will be checked. Result will be failed.
What?
Condition will be checked, but result will be failed.
Yes,
I mean,
but it
it
will
will not
return the
enter to the if
false.
condition. Yes.
Huh. The condition it will check, it will just give me the false. So it will stop. These steps will not be executed. Similar
Right.
here also. Because second maximum is 56. 56 is not greater than 82. So again, the condition fails. These steps will not work. Is it clear?
Yes.
Great. Now let's say the next value is of uh, 52. Now what will happen?
Okay, so the third max only will be get updated. The first two remains the same.
Yes. Here, so you all can able to understand these steps, right?
Sir.
So can you all be able to understand all these steps, or you want me to say it further, people?
Now this will not work, right? Because X subject is 52, max is 82. So
Huh.
this will not come.
Yeah, so only the third maximum gets updated because now 52 is the maximum. I mean, third maximum.
Yes.
Yes. Now tell me, people, do you want some more example to understand this?
No, ma'am.
Great. So this is how you can just do it for all the three subjects by giving the same with a different parameter like maths, physics, and chemistry. So next thing is, let's say I have to check for the people who has scored in like maths who has scored higher, like maths physics who has scored higher, and all the three who has scored higher. Is there any person who has scored higher in all the three subjects? So to check that, what can we do, people? To find the overall toppers.
You can call a procedure, right? There,
Yes, what has to be the conditions for that? That is the question.
you can check if, say, a given subject, if so we can check between, so for every student, we can check for every other student. If
Yes.
if
Or
the
else,
other
yeah, continue.
yeah, or else if we find that, say, y is less than x, we don't update that.
Hmm.
So only we update only if x is greater than y, and then append the list of the
Yes.
sequence numbers.
Yeah.
Or for every subject, we can look for the maximum mark.
Hmm.
For every subject, look for the maximum mark or the
Okay.
topper in that specific subject.
Hmm. And by that way also, we can be able to check with the top three students. Okay. So that is nothing but we are just getting the mark, and whatever the value it is returning, we have to check. So generally, this top 3 marks is returning the third mark. I mean, third maximum is returned here, which means that is the least mark they can just score. I mean, like that is the first, like top third mark, right?
Yes.
Let's take this example. In this, which is the third max? $52. So
Right.
52 is taken for some subject, let's say. For other subject, let's say the third max, because I'm just taking only 4 elements. Let's say I'm taking all the data set and all. Of course, minimum 80 will be the 80 or 70 will be the minimum, right? So in that case, let's say one subject they have scored 71. In another subject, the least mark is 82. And in one more subject, let's say the least mark is 90. Okay, so now these will be stored in the cutoff marks. And then we are taking a list. And then we are trying to find who are all scored more than these marks. So only those people will be the 1 and 2, right? Is that thing clear, people? We are just taking the third mark of each subject. And then we are just going to take the first 2 subject mark, which means whosoever have scored more than 90, they are considered as the top 1 and 2, right?
Right.
Is that thing clear, people?
Ma'am, could you please repeat what is the objective actually? I just misunderstood initially.
This thing, can you all able to understand this?
Yes, ma'am.
Great. So after this, what we have to do is, let's say if a person has scored more than 90 in one subject, which means the top score, let's say it's of 93. The second maximum is 93 and the first maximum is, let's say it's 97. So more than 90 in the sense of 97, 93. These 2 marks, whoever has scored, they'll be considered as the toppers of that particular subject, right? Can you able to
Hello,
understand this?
ma'am.
Yes, you're
Just
audible.
I have the basic, I mean the initial doubt actually. What is the
Mm-hmm.
objective actually? Do we have to find out the student who has scored top marks in all 3 subjects, uh, or it is subject wise you have to find the top mark?
No. Actually, let's say a person has scored 93 in one subject, another subject he has scored 71, in another subject he has scored 85. He is one of the topper, right? Because he has topped in all the 3 subjects. Because he has scored a mark of first 3 in all the 3 subjects. He is considered as one of the topper. Can you able to understand?
Yes, ma'am. Yes.
Yeah, we are trying to find who has scored in top 3 in all the 3 subjects. There can be some person who has scored 97 in one subject. In another subject, he might have scored 70. In another subject, he might have scored 82.
Yeah.
He is
Yes.
not considered as a topper, right? Because he hasn't scored the top 3 mark in one subject. Can you able to understand this now?
Yeah, yes, ma'am.
Yeah. Similar way, they are just taking the sequence number of whosoever has scored more than that cutoff mark are taken in separate maths list, physics list, and chemistry list. And then they are taking the elements from the maths list, which means the sequence number. If the same sequence number is present in this list, then he is considered as the topper in maths physics exam. Okay. And maths physics list, you will have some sorted names, like that is compared with the chemistry now. So if the person's list is there, then those people are considered as the toppers of all the subjects. Is that clear?
Yes, ma'am.
Is any doubt so far, people? Yeah, please say. Do you have any doubt?
Ma'am, one question. In the if statement, why they are comparing x is equal to y?
Which means if the sequence number in the maths list is equal to the sequence number in physics list, then that person's sequence number is added to the another list. Because in maths list, you can see here, right? We are just checking whosoever has crossed the sequence cutoff mark, we are adding their sequence number. So that will be the elements of a maths list. Similar
Yeah.
with physics and chemistry. So that's why
And
they're comparing the sequence number. If it is the same sequence number, they are the top.
and then cutoff is the third max, right?
Yes.
Oh, all right. Thank you.
Third mark is taken as the cutoff, and first 3 marks, which we can compare it easily, right? Because whatsoever who has scored more than the third mark will be the first and second scorers.
Right.
Yes. So this is how we can just find the toppers and all, right? Okay, so here we are trying to find the common elements in the list. Is that clear? Is
Yes,
everyone
ma'am.
any doubt?
No, ma'am. So far, so good.
Okay. Okay. So these are the list functions, people, like length of, first of, last of, rest of, and init of. Can I all say what is mean by first of?
The first element in the sequence,
Okay, what is mean by last of?
last element in this sequence.
Okay, how about rest?
After removing the first one,
Exactly. So after removing the first, whatsoever elements are there, that will be considered as the rest of the list. How about init?
removing the last one.
Exactly. Can you all able to recollect this, people? Remember this? People, please do respond now.
Yes, ma'am.
Yes, ma'am. Yes.
Cool. So let's say if I'm taking an element using a first of, and then I'm giving a rest of means, let's say I'm giving us first of, rest of list. Now which will be taken? Let's say the element has 26, 10, 12, 6, 7. This is the list. So what will be taken as the answer for this?
10, ma'am.
How it is 10?
Init will be the init rest, right? Rest will give the excluding, the first element. It will be starting from
Yes.
10 to the rest.
Perfect. So in that we have like first we have to solve this rest of L, which means only
From
these
10,
elements are taken. So in which I have to find the first of list, which means 10 will be taken. Is that clear?
Yeah.
All
Yes, ma'am.
right. Similarly, let's say The same thing, I'm giving it like how about now? What is the answer?
10, 12, 6, 7.
10, 12, 6, 7.
Yeah, ma'am.
No.
It'll be
10, 12,
fine.
10,
Rest
12,
will
6.
Yes, perfect now. Because rest of means, what is mean by rest of people? It has to take the elements from 10, 12,
10 to
6, and
7.
7. In
Yes.
that, we
And
have
then
to do a
again,
init. Init means remove the last
removing the
element. So,
right.
10, 12, and 6 will be the answer. Is it clear to you all people? Or you want some more example?
It's clear now.
Great. And before that, do you have any doubts in this week 5 content, people? Any doubt? Okay. What is meant by nested iteration, people?
Iteration within an iteration.
Yes. Can you say any example for that?
Yeah, iteration of the
matrix.
double dimension array.
Yeah, matrix
Ah,
will be there, right?
yes, perfect. Which means how will you iterate it, people? Let's say I'm taking a list L. So I'll give it as for I in L. Let's take example as 1, 2, 3. And then I'm giving us 4, 5, 6. And then I'm giving us 7, 8, and 9. Now, for I in list. So what will happen here?
For I and L. And then
Yes.
again for J in I. And then
Yes. Then,
and then consider we have to print. So print I and J.
yes. Which is nothing but I have to take a list I first, which means this 1, 2, 3 is taken as I, in which I have to iterate. That is for J in I. So 1 will be iterated, 2 will be iterated, and 3 will be iterated in this. Okay. Similarly, during the next iteration, 4, 5, 6 is taken as I, and J is taken as 4, 5, and 6. Is that clear? Is this clear, people? So this is what we'll say it as a nested iteration, which means inside the iteration, we are trying to iterate it again. Is it clear?
Yeah.
Great. Okay, so now sorting the list. What does mean by sorting?
Arranging in order.
Yes. In what orders we can arrange it possibly? What are the
Ascending.
possible orders? Yes. Ascending in the sense of
Higher than
Ascending.
from
bottom
low
to
to high.
Yeah.
Yes,
to
low to high, we'll just use it as ascending order. And similarly, we can just use it as descending as high to low, right?
Yeah.
So here we have some sorting techniques using which we can be able to sort the elements. Okay. So let me just. Yes. So first we are trying to insert the elements into the list. So let's say first a new list is taken. Okay. Okay. So first in this we are going to use only the like insertion sort. What is meant by insertion sort? Insertion. Yes, people.
Inserting
So
an
you
element
insert
either at the
an,
beginning or at last.
you
Beginning or at
insert
the
an
last?
element and you insert an element and you compare with every element in the given list and check if that list and check if that element is either less or greater than the element, and then you append in the list.
Yes. It's nothing but we are trying to insert in a particular position, in its correct position, in fact. Let's say we have a elements as 26, 10, 12, 6, 7, and 91. Let's say these are the array elements. So it has to be first, what is the first element here?
26.
26. So initially, is that in a correct position? When I have only one element, 26 is in the correct position, right?
Yes.
Okay. So here I'll have a line. Then I have a 10. So here I have the elements like 10, 12, 6, 7, and 91. Now 10 is, if I try to insert 10 here, where should I insert? Is 10 is greater or lesser than 26?
Yes.
Lesser than 26.
Yes, it's lesser. So where I have to insert
Before
10, which is on the left side of it, right? So the array has to be in such a way that 26 and 10, and then we have to take that line. So which means this line indicates what are the elements before this line. Left side of the line are sorted and the right side are unsorted. So to indicate it, I'm taking it in such a way. Okay, and then I'm taking 12. So now what happens? To which element I have to check that first?
Check for 12. Check with it.
Initially, it has to be checked with 26 or with 10.
with 10.
Yes, it will be checked with the 10 first.
Initially, it will check with 26, right?
Why so?
Will it check with 10 or 26? Actually, it's with 26. Okay, first it will check with 26. If the element
Why
is
will you check
lesser,
with the 26?
because this
Why
is the
will you
end
start
part,
with
right?
the low? Yeah, why will, that's my question. Why will we will start with the end part? Why not with the beginning part?
Because the number may be greater or lesser, we don't know. Let's say I'm starting from 10. What if the number
See,
is
this
greater
condition,
than that?
yeah. So similar condition value will be in either side, from beginning or from last.
I didn't get it.
12, I mean to say that where 12 will be fit, we don't know in advance in the sorted array,
Yeah,
right?
what if
So
the
it may
value
be
is
from beginning or from the last. So we can, so either way, either way we can start, or we should start from last. Is any advantage?
okay? So now I have to insert 34. So
Right.
generally what I'll try to do is, if I check it with 10, I have to check with all the other elements again, right? So if I just check it with 26, which is the last element, if it is greater, it has to proceed further. Otherwise, it can just insert before or after. Let's say if the 34 is greater, just one step is fine. If the value is lesser, then I'll compare it with 19. Is it still
Consider,
lesser? I'll
yeah, I convinced with your example. Consider is instead of 34, it's
But that
only
is the
4.
no. Actually, this is the algorithm. So that is the steps to be followed.
I understand, but consider number is only 4. Then you have to iterate whole list. 26, 9, 18, 12, 10, and then you will insert 4.
Yes, actually, that is the algorithm, right? So if I have to do an insertion sort, this is the algorithm.
That this is my question. In algorithm, you put that we will insert from the from the last element to the first element, right? This is the order you will follow. But what is the advantage of that? This is why I will not start from beginning to last, because in either case, one edge case you gave me that 34, I'm convinced, but there it could
Okay.
be
There
another
can be a
number which is
multiple
4.
cases also. Yeah. I agree to that. Let's say the value can be 3 also. In that case, it has to compare with all the each and every element, and then it has to be inserted here.
So it doesn't matter whether we start from beginning or we start from the last. Does it matter?
Actually, we should start with 26.
I understand from your algorithm, but in algorithm, why we will not write
That
from
is the
beginning?
insertion sort
See,
algorithm itself.
then yeah.
Let's
But
say
this
if
is the
you're,
point
let's
I'm
say
not
we are
able to
taking a
understand.
bubbles. No, wait. So we have a different set of algorithms, right? Bubble sort. Have you heard of this word bubble sort?
Yes.
Okay, in bubble sort, what will we do? It has some algorithm, right? I have to compare 26 with 10. Sorry, let's say I have to insert 12. So I have to check with all the other element, and then I'll just keep swapping the element, and then I'll try to do it, right? Like every adjacent element are checked, and then it will swap it. So that is what bubble sort do, isn't it?
Okay.
So initially, if it is a bubble sort, first 26 and 10 are compared. 26 is greater. So sort it as 10, 26, 12, 6, 7, and 91. And let me add 3 also. Then what it will do? These two are compared. So it will keep it like this. Then these two are compared. So this is the algorithm, right? So bubble sort means I have to check with the adjacent element and I have to swap it. That is the algorithm. Similarly, insertion sort has an algorithm that we have to check. We are dividing into two paths. One is this line
Sorted
indicates. Yeah.
Sorted array.
Left to that is a sorted part, and the right part of it is a unsorted part. So whatsoever the array is given. So this is how it has to check. So in the sorted path, I'm just checking with the last element, and then I'm trying to move forward. That is the algorithm we are following. That is the insertion sort algorithm.
So if in the same algorithm, if I doing from beginning to the last, will that make any difference? Those
Actually,
insertion sort.
yeah. Actually, in insertion sort, it does said to be a in-place algorithm. So in place in the sense of, let's say I'm comparing with 26. If it is lesser, I'll just insert this 26 to this position, because here I'm not trying to use any extra elements. If I compare it here, anyway, I have to swap all the elements, right? Let's say I'm comparing 3 with 10. If it is lesser, how to place it there? Anyway, I have to shift all the elements, right? So that is the major thing. We are going with the last. If 3 is lesser than 26, so the array will be like in such a way that 10, 12, 18, 19, 26 and 26. Still, in some variable, the 3 will be there. Now, it is checked with 19. So, 19 is greater. So, instead of this, 19 is changed. Now, 18. So, this place 18 is changed with. Here, it is changed with 12. Here, it is changed with 10. This position, it will be inserting the 3. It's like overwriting the same array with the different values.
So why we will
If I
not
start from
overwrite
the
from
first,
the
wait,
yes.
if I start from the first, how will you sort? How will you like insert it? Can I insert it straight away in the place of 10? No, because array has elements from 0 to n minus 1. So only in the 0th position I have to insert 3. So I need to take a copy of all the elements, right? So instead I have to take a copy of 10 and I have to insert it in the first index. But first index, there is some element is 12. That has to be pushed to the second index. We have to do this procedure now.
I got it. Thank you.
So that's why we are just using this, because this is a in-place algorithm.
No, I clear. Thank you.
I hope I have answered your question, right?
Yes, very much.
Okay.
Because
Thank you,
this context I was not able to incorporate, like since it's in the we are moving into the same array, so we have to move it, and
Yes.
the comparative element is in the last the other side, so we have to go from the last to first, not first to last.
Yeah,
This
first
has to be done.
to last means we have to just take a copy of it and we have to store it somewhere else. So that creates a little issue, right?
Yes.
Yeah. Okay, so they are just using the sorted list, and yeah, this procedure is followed. Okay, so first they are checking whether the value is inserted or not. Initially, the list will be empty, so insertion will be false. then they are taking the element from the list if not of inserted. What does mean by not of inserted?
And it's not in sorted array.
Yeah, which means it's false. Not of false is true. So if of true, it will check whatever is the x value so far. So x value is the value to be inserted. Let's say it's 2. It will check whether 2 is less than the elements in the list. Let's say it's 36. Okay, is it lesser?
Yes, less.
This condition is true, right? If that is the case, add it in the new list. And I have inserted 2. Like that, I am just portraying. Okay, and
Right.
then in the new list, I'm inserting the 36 also at the end. Like all the lesser elements are inserted, and then I'm just inserting the 36 at the end. Okay, now inserted is true. So this procedure will not repeat again because it's inserted. Imagine that we have a value as 12, 92. Now is 92 is lesser than 36?
No.
No. So what will happen? This is inserted as false. It is true. It has become true here. Is this condition is true? No. So this part will not work. Then what will happen? Again, it will check by taking the new value, right? Because I have checked this, it is not working. This if has no other else part. So here it will add the z, that is 36 is added. Then it will take the next element. Let's say the next element is 52. So again, what will happen?
52 will get added here.
Yes, again the condition is false. So 52 is added into the new list. Let's say I have the next element is 89. So 89 is also added. And then I have a next element as 95. Now what will happen? The inserted become true, and then I'll try to insert the 92 here, and then we'll insert this 95 at the end. Is it clear? This is the way of just sorting a simple list. Is it clear, people?
Yes, ma'am.
Excuse me. All right. So this is the way to normally sort a simple sorting way, people. Okay. This is to sort it in the ascending or descending order, which order it is.
Ascending order.
Ascending order.
Yes. If it is descending, I have to just change the symbol. That's it. That is by checking what side I mean, like we have to check for the lesser element, and that has to be inserted at the end. That's it. Is it clear, people?
Yes, ma'am.
Okay. So you can see here, people, the the 6th week consists of a systematic process of hypothesis verification to find, which is nothing but, let me tell you, here we are trying to find a subpart because you have seen, right, the whole list is there, but still we have a 2 subparts. One is a sorted and the other, after the line, it is completely of unsorted, right?
Yes.
Do you all remember the insertion sort, people?
Yeah, there is 2 parts.
Yeah, let's say there is some division line. So the elements in the line left side are sorted and the right side are not sorted. Do you remember that? I have just drawn
Yes.
some line. So let's say
Yes,
3
yes.
is here. I'll just check 2 elements. So this side is of a sorted one and all these sides are an unsorted one. Though it is the same list, I have a 2 parts, right? So we have a we are trying to take the sub part and we are trying to solve the solutions. And we are just checking how it is related and all. Okay. So here, what they are trying to do is we have to take a thing that a person who has scored a good mark in maths as well as in the physics, which means what has to be that? The person has to score good mark in both the subjects, right?
We have an and operation between them.
Yeah. Okay, so here they are just trying the building the marks list, which means we have a mark list in which they have a sequence number and then the what field they are taking, which means like which subject it is. Okay, if it is of maths, they'll just take it for the maths. If it is of physics, they'll just take it for the physics. Okay, and then in the sorted element, they are trying to take the last and the first elements, because let's say if I have just the order like the sequence number is of 1 and he has scored some 56, and sequence number is 2, he has scored some 43, and 3 and they have scored some 90, something like this. So there will be a list like this, right? So in this case, I'm just building for max. Now I have to take the sorting. So if I sort it, what will happen?
243, 156, 390.
Let me give here a 69, and the 5 can be of some element number 82 like this. Then now it will be sorted in such a way that if it is ascending order 1 and 56, sorry, 2 and 43 will be the least, right?
Yeah.
So 2 and 43 will be the first person, and then 1 and 56 will be the next person. Next person is of
469,
469. Yes. Then
582, 390,
yes, 582, and the
390.
next person is 390. So in this, how to get the highest value?
The last one.
Yes. So if I want to know the topper, I can just take the last of. Is that clear?
Yes, ma'am.
Similarly, I can do it in a physics and then I can compare both their marks, right?
Yes, ma'am.
If they are like scoring, if both the sequence number are same, then they are the topper. Otherwise, we'll just go ahead with the next person. Okay, so this is how we are trying to identify the toppers in that. Okay, is that clear?
Yes, ma'am.
Yeah. So in this, they have used one more data set is nothing but the train data set. So here, they have two things. One is the terminal and the station. What is meant by terminal and what is meant by the station?
Terminal where the train ends or the starts,
Mm-mm.
and terminal can also be in a station, and any station between the terminus are also stations.
Yes. So terminal is nothing but like you can say, right, like that is the end point of it. Okay. And yeah, so here they would have discussed about the train numbers. Like let's say I'm taking a number as 12286. So it goes from A to B. So there will be a train from B to A, right? So the same destination, but with a one number change. You might have noticed in the expresses and all, right?
Yes, ma'am.
If it is going from one city to another city, they'll have one number. If it goes in a vice versa way, we'll have one number changed. That's it. Is that clear?
Clear, ma'am.
Okay. So here they have discussed about the train data set and then the station data set. Like both the data sets were taken and they are comparing whether like if I have to go from one city to another city, what are the possible trains I can take, or what are the routes are there like that. Okay. So this is all about week 6. And week 7 containing the dictionary. So what is dictionary, people? Do you have any idea?
Yes, dictionary stores the value in key value pair in order to fetch the data in random manner.
Yes. So it has a key value pair. Okay. So based on, let's say I'm taking the value as sequence number 1. So there's our, let's say their total is 50. So this is said to be a key colon value. So this is the general syntax of this. Is this thing clear, people?
Yes, ma'am.
And here we have discussed about, it is discussed about the dictionaries and how to use the dictionaries also. I'll just yes. So this is the like yeah. So this is the example of a dictionary, people. So it should have a key value pair. Okay. So here they have taken the key as Rahul and the value was 92. It's their mark. Here I have taken as the like for example, I'm taking this as the sequence number as a key and their mark as the value like this. So generally it has a key value pair within the braces. So this is said to be the dictionary. Is that clear?
Yes.
Great. Now, how to iterate through the list? Sorry, dictionary. We can iterate through the dictionary in such a way that we can take the keys in one and for each k in keys of D, which means it contains a list of a key. Here, this is, let's say, D is a dictionary. K is equal to the value, which means dictionary of key is equal to the value. So this is how we can be able to access the value of the particular key. Is that clear?
Yes, ma'am.
Yeah.
Okay. So we can just get the keys using keys of method. But if I give keys of D, all the keys should be accessed and we can just iterate through the keys. By that way, you can be able to access the values. Is that clear, people?
Yeah.
Yes.
Okay. Okay. So here, what are they trying to do? Can anybody say that?
That calculating the average count, the average of the chemistry marks here. So they're starting with,
Yes.
they're initializing the total and count, these two variables to be 0 initially. And if there is a, for if there is a key, had there not been a key in the chemistry marks dictionary, we would have created the key. But since we have the keys, so we iterate through the keys and we add the total marks to this total variable. And for each, we increment the count. And
Yes, it's
we,
nothing but we are trying to take their values. Like let's say here it contains all the elements of the chemistry, like chemistry list containing all the values of the data set. So here all the chemistry marks are added to the total. So whatever like chemistry of K means the dictionary will be like let's say the sequence number is 1 or name can be whatever it is. So their mark is let's say it's 50. Then 2 has scored 89 and 3 has scored 69 and let's say 4 has scored 58 and 5 has scored 92 and 6 has scored let's say it's 43, something like this. So I'm taking the key. So D of, as I mentioned earlier, D of K is equal to, we'll get the value here.
Value.
So if I give it as D of K, so 50 is taken, that is added to the total. Then count is incremented by 1. So one person has scored 50. So on taking 2, it will try to add 89 plus 50, which means 139 divided by, like as of now, its count is 2 and total is 139. So next is 3. They have scored 69, so that will be added to it. So similar way, it will try to add all the 6 elements. So total divided by 6 is nothing but it gives the average value of it. So this is the way to process, like way to iterate through the dictionary. Is it clear?
Yes, ma'am.
Great. And you can check using the is key of by giving is key of D comma dictionary and then whatever the key value is. So here it will give me the value as a Boolean value. If the value is true, means the value is present. If the value gives us false, then the value is not present, which means the key is not present in that particular dictionary. Is that clear?
Yes, ma'am.
Yeah. So here they have given it in the if condition. So if of is key of runs comma Virat Kohli, which means if the Kohli is in the runs dictionary, then the present score is added to the runs. Whatever is the previous value in that the present score is added. Otherwise, they are creating a in the runs they are creating a like in the dictionary they are creating a key as Kohli and value as Kohli. If already value is there, we are trying to add the value of the person. I mean, like whatever is the previous value, try to add the present value to that. Is that clear?
Yes.
So this
Yes.
is the way of checking whether the key is present or not using the is key of method. You can just use this procedure, people. Can anyone say what is given in this procedure?
This iterates through the key and then finds whether the given key is present in the list or not.
Hmm. That is nothing
The
but
key
first initially they are giving found as false. Then they are trying to iterate each element, like whatever the present key is given, k is given, they are trying to check whether that is present in the list or not. If it is present, they are for giving found equal to true and they are stopping the loop. Actually,
Right.
here one more line has to be added, that is return found. Because if it, okay, only exiting the loop, okay, fine, fine. So they are just exiting this whole loop and then whatever is found, like, which means the true will be written. Imagine that it is checking through all the elements. Still it is not there. So what will be the found value? Will the found value be updated?
No, then
no,
it will
ma'am, it
be
will be
simply
false.
false.
Remains false.
It remains false and that will be written, which means the key is not present there. Is it clear, people?
Yes.
Great. Can anyone say what this procedure means?
The number of customer who bought the food. The number of customer in the category of the food.
Is it number of customer or
This, something like
No, no, no.
each customer
Frequency of
who
the
bought
customer.
the different categories of food categories.
here only food is checked, right? So how many people, like let's say I'm taking a customer, if that customer has bought a food in the, I mean like the category is food, then they'll be added to the dictionary by adding one. Which means like initially, let's say they have purchased like 2 food items. Now the purchased food item will be added as third food item. If they are not in the dictionary at all, then
It will
Then
be
that
one.
customer will be added
yes,
Then
it
you
will be
create a
adding the
through
new
the
one.
else part.
Yes, it will create a new name with the item purchased as one. So
and
by
then you
this way, it is trying to
increment.
add who are all the customers who bought the food as a, like in food category, if they have purchased any one item, that is added. Minimum one is added. Maximum, it can keep adding it, right? Is that clear, people?
So which means this will give the number of food items bought by the customer or number of times the food item bought by the different customers.
I didn't get you.
This result of basically the food will contain food is a list here. Food is a list here. Now food is a list here. Is it a list or dictionary? It is a
Dictionary.
dictionary, ma'am.
It's a
Dictionary.
dictionary.
Yeah. So which means say that food. Okay, which means this will contain food is a dictionary which will contain the customer and then customer as a key, value as a item category, which is the food that customers bought. So which
Yes,
means
yes.
for each customer the number of times the food category they purchased, that count will be there. Is it like that?
Yes. Yeah,
Okay.
yeah. Based on the food category, how many times they have purchased. Let's say now they have a like number of rows they are taking, okay? Which means like for the sequence number 1, I'm just taking a card. And for that, in that card, how many food items were purchased? The food category can be like 3 food items they have bought, which comes under the food category. So it will be added as like that. If the key is present, there'll be like whatever the previous value, they'll add 1 to it. If that category is not present, they'll create a new category to that. Is it clear?
So which means no, the one customer no bought no 3 times no food item. The item category no three times. They purchase no the food item. So that then it will the customer C will contain the value as a 3. Then is it like that?
Yes, yeah.
Okay.
Because here we are checking is key is present, just add 1 to it. If not, create a 1. So if they have already purchased 2, the currently purchased 1 will be added to it and it will show it as 3. If they're purchasing 1 more, previous value was 3, current one is added, so in total they have 4, like this. Is that clear?
Yeah, yes, ma'am.
Great. Okay, what this mean? What this procedure indicates?
The two students have the same birthdays.
Okay. Only two or more than 2 can be possible.
Yeah, more than 2 can be possible. Yeah.
It can be
We are, we are,
multiple
we are
possibilities.
checking. Yeah, we are checking pairs of students who have birthdays on the same day.
Not pair, right?
A number of students who has the same birthday.
It's nothing but, let's say if a person, I'm taking the card, they have a birthday date on okay, 28th April. Then that person will be like initially birthday dictionary and duplicates dictionary are empty. Okay. So I'm taking a card. In that I have taken the card number and the sequence number also. I have to check whether the key is present in the birthday date. Initially, is it present? Initially, what is the birthday dictionary is?
Empty.
Yeah. So there will not be any elements into it. So will this condition be true?
No.
If condition is true, no. So the statements below that will not work. It will go to the else part. So what is there in else part? So now 28th April is added to the birthdays dictionary. Okay, so now in that I'm adding the sequence number, which means on 28th April is taken as a key in which I'm creating one more dictionary. Can you able to see this line, people?
Yeah, this
Yes.
is true.
So it's like we are creating a dictionary inside a dictionary, nothing but a nested dictionary. Inside which 28th April is a key and the value is a dictionary in which we are adding the sequence number and the
Is another key.
yes. Now
Yeah,
one is
status
the
of the
key.
sequence number.
So let's say if I have a second person. Now what will happen here?
The sequence number will get added if he has the same data.
So sequence number will be added in the birthdays as well as in the duplicates.
Replicates.
Now the duplicates dictionary is open in which key is the same 28th April. And what is the value here? It is 2. Similarly, if it will just take here, if it goes more than 1, which means if the key is present in the birthday dictionary, then that will be added in next time. It will be added in the duplicate as well as the birthday. In birthday, it will just add the sequence number. Here, it will take as a duplicate. Is that clear?
Yes.
Can you able to understand this, people?
So duplicate will always be Boolean operation, Boolean
Huh.
representation. Okay.
Yes.
Mhm.
So this is how we are trying to find how many people are there containing, like which is the common birthday date. Is that clear, people?
Clear.
Do you have any doubts so far? Okay. And here they have taken the two more dictionaries just to imply the customers and then their spending, like in what purchase, in what items they are purchasing and on what they are spending. So that will be taken into the dictionary and they're comparing the values also. So that is also covered in the week 7. Is that clear, people? Do you have any doubts so far? People, am I audible?
Yes, ma'am, you are audible. No
Yeah.
question.
All right, people. Okay. So now proceeding with the 8th week, in which it contains a dictionary. So in this one, we have discussed, no, like dictionary inside a dictionary. Similarly, we can just give a word as a, I mean, like some key, and we can use a list as a key also. Sorry, value also. Okay. Instead of dictionary, we can use a list as well. So that is what is discussed in the like primary of week 8 is that. Okay. Can anyone tell me what is given here? I'll just give you 3 minutes of time, people. Just understand, observe, and tell me what is given here.
Checking for common elements in two lists.
Okay, how are you saying that?
See, when if you take two lists L1 and L2, it says that if L2 equal to 0, then you return
Okay.
overlap, and overlap is
I'll,
an empty list. It returns overlap. So
okay.
otherwise, so the part where you compute the common elements is given by this the third if loop.
If is a loop or if it's a condition check.
Yeah, I mean the if is the if condition, the 1, 2, 3, 4. Second if condition.
Okay. In second if condition.
Yeah, if x equal to y, so you find that if there is a x and there is a y, for every x you check every y in the list two. If they are
What
equal,
is y and what is x?
so these are two elements in these two distinct lists.
Okay.
Okay, so if x equal to y, so let's say x1 equal to x2, then only you compute the overlap. So the overlap list would be appended with the elements x1, or let's say x here, and returns the overlap elements. That is the common elements between the two lists.
Okay. Is it affecting any values in the list or something like that?
The next,
Okay. After this
no,
procedure, if I try to print a L1 and L2, will it be same or not?
no, y would be different. I mean, L2 would be different, right? They
Why
would,
so?
because of this, the first for each condition. So in the while condition, if you have this y is less than x and a length of L2 is greater than 0. So y is,
Actually, every now and then, as you mentioned, it's right. So you can see here, right? Here we are taking the rest of L2. So we are trying to get the length of the L2 to be 0 because we are cutting down the element using the rest of, right? And here also, if the condition satisfied, we are cutting down the elements. So L2 will be changed. So how to solve this? Yeah, how to solve this, people? Any idea?
So you want me to explain the, what is going on inside the algorithm? So in the for each x in the L1, we read the first element from the L1 and we are checking with the y. Y we have already taken the first element from the L2 and we are resetting the L2. So if x is equal to y, then
Yeah, I'm saying that how to store the like L2, because in this one we are just altering the L2, right? So I
yeah,
don't
L2 is,
want.
when we have, went with the function rest L2, it means from the first, after removing the first element, rest of the element is, keeping updated into L2.
Yeah, my question is it possible to create a L2? Like,
Hmm.
is it possible to maintain a L2 without any alterations? Here, L2 is altered, right? So it shouldn't be altered. So is there any way to make it unchanged?
Then probably we have to
We can
maintain the
copy.
another list.
We can copy L2 into other list.
Yes. So this is the, like, here the L2 gets changed. So to avoid it, what I can do is I can just take a copy of the L2 in some other list, and then I can just alter that L2, like modify, like to whatever the list I have created a copy. In that I can just I can just alter these things. Is that clear?
Yes.
So actually this is said to be the side effect, which is nothing but I'm altering the element. It shouldn't be done. So we are taking a copy of it and then we are trying to do the process in that. Is it clear? Is this clear, people?
Yeah, but why it is
But
called side effect, ma'am?
go to the
Which
last
means,
previous slide. Go to the previous slide where L2 inserted. Yes. So here in the procedure, we are, passing the, L1 and L2.
hmm,
Since we are passing the L1 and L2, so if I will make any changes in the L2, so it will affect the original. Eh, Are we passing by reference?
actually it's like we are altering it, right? Like say if I'm just, okay, let's say if it is not the procedure also, if I'm trying to do the changes, anyway, it's modified, right?
Yeah, then it's a, different edge case because when if, since it's, my value has been passed to the procedure, the life cycle of the L2 is within this procedure, not outside. So even if, it's altering, then what is the, point
What
to
if the L1 and
restoring
L2
the.
are like general values, like which means like its scope is general?
See, if L1 and L2, coming as a pass by reference, then it may make sense in the original function where we don't want to get it changed. In that case, yes, it makes
I'm
sense.
saying what if it is a global one?
Then definitely it makes sense to, restore the value.
Yeah, so that's a better way. Like we are taking a copy of it and we are just doing it, doing the procedure, whatever is required. Like if I have to alter it, whatever we have to do, we can do that.
Okay.
Okay.
Got it.
So similarly, we can be able to delete a key from the procedure also.
Ma'am, why it
That
is
is,
called side effect, ma'am? Sorry.
I didn't get you.
Why it is called side effect?
Uh, which means we are trying to alter it, right? Like we are just there is initially it was something, and I'm trying to make some changes to it. So I'm just creating some effect to that, right? I'm just affecting the original list.
Okay. Understood. Clear.
Okay, any doubts so far, people? Just for you can just more precisely we can say that just to get the output, I'm making some changes to that. I'm just purposefully affecting the original thing. Fine.
Clear.
I'll try it. Okay, so yes. And the eighth week also containing the dictionary comparison to find the common elements in them, which means, let's say they have taken the, what they can say, ah, they have taken the train and the stationaries. So how to find the common elements in that? We have a two data sets, right? One is the train data set and the other is the station data set. How to find the common elements in that?
Train numbers,
Okay, then
station.
yeah. So what we can do in that is we'll just try to find out the, let's say I'm taking a station named Pune. So from Pune, what are all the stations, or like what are the trains are going from that station? I can just note down those stations and then I can just take the train numbers, and then in that train number data set I can just try to find the stations. Is that clear?
Yes, ma'am.
So let's say from Pune, there can be multiple trains to reach the particular station, right? I can just take a note of this and then I can find the common elements in that. So that is the way to find the common element in the dictionaries. So this is all about the week 8. Do you have any doubt in this so far?
No, ma'am.
Great. Then we can just start to discuss this PYQs, people. Okay. So what will be the answer for this question?
This will be a 9, ma'am.
How it is 9?
Let's say
See,
we
for,
start
we
with.
have,
Okay, yeah,
Can
sure.
anyone explain with
yeah,
the,
go
like,
ahead.
how the
Go
procedure works?
ahead. No issues.
Go on. Yeah. Yeah.
Okay, now we are starting this function now with 3 comma 2. When
Okay.
the procedure invoked with the 3 comma 2, x is equal to 3 and n is equal to no 2. Since n not equal to no, n not equal to 0, it comes to the else. So return x multiplied by do something x comma n minus 1. Again, it is a recursive call. X is equal to no 3 multiplied by do something with the 3 comma 2 minus 1. So
Okay.
3 multiplied by do something again invokes no do something again the recursive, where in that iteration n not equal to no 0. Already we have no 3, again this time again 3, 3 multiplied by 3 multiplied by and 2 minus 1 1.
Okay. 3
So
comma
again,
0.
yeah, so again in this case again 2 comma 1, yeah, in this case no 0, since n is equal to no 0 it returns no 1, 3 multiplied by 3 multiplied by 1.
Then I'll get it as 1. 3 into 1, I'll get the value as 3, which is the answer of like function of 3 comma 1. I have got as 3. So here 3 cross, what is 3 into 3?
It's
9.
9.
So that is the value of function of 3 comma 2. So here option B is the correct answer. Is it clear to you all people? Okay, here is the next question, people. Now tell me what is the answer. I'll just give you 3 minutes of time for this.
The answer is D, which compares both the list.
Hello.
Yes, you're audible. Can you please tell me how that works?
Yeah, I can explain now. So
Yeah.
for the first time, when the procedure is now called, it checks now for the length,
Okay.
whether the length of the no both the list are not equals. If they are
Okay.
not equal, it returns a false. Since for the first time, say for example 2 comma 3 comma 5, I'm going for the option A, and 2 comma 4 comma 5, the first condition fails. Okay, so it returns, come back to the, it comes to the while. It checks for the length of the list one.
Oh,
The
if
length
it
of the list
returns
one is no
false.
3.
Okay. Yeah, please.
Yeah, it won't return actually for the first citation. It checks only for the length. 3 not equal to no 3, right? Since
3
the
is
3 not
not
equal to
equal
no,
to 3.
yeah, I'm going option by option, ma'am. I'm explaining for the option A.
So, okay. 3 not equal to 3. The if condition fails. Okay. Yeah.
Yeah,
Continue.
then come it comes to the no while, and then it checks
Yes.
length of the no L, L1. So length of the L1
Mm-hmm.
is no 3. 3 greater than is equal to no 0. Greater than 0, yes, condition no true. Then checks no for the last of L1, which is not equal to last of L2. For the option A, last of L1 is no 5 and last of L2 is no 5. In this case, both are equal.
Yes, 5
So
is
the
equal
condition
to.
5, yeah, the condition fails here now. So it checks, then it picks up the no init. Init of no L1 returns the uh, list of item excluding the last item. So
Which
in this case, it is
means,
going to be 2 excluding the last one. So 2
yeah.
comma 3 and then 2 comma 4.
Yes, perfect.
Then checks for the length. Again, I come back, comes to the while, and the length of the L1 is no 2. 2 is greater than 0. Condition satisfied. Then comes to
Yes,
the no
one
if.
minute, Vijay Raghavan. Can you start from this step? Can you anyone explain other than him?
Yeah, sure.
Uh,
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 but you can. So the essential checking is done by line 6 and 7. So the catch would be to identify all the last elements. I mean, last after doing init, and every last element after doing init would return eventually true. So you need to check for those statements for which this thing returns true. And if
yes,
you go
in this
step by
case, in the first option, like here 5 and 5 were true. So it will go to 4 and 3. What happens to this condition check? It will return as true or false.
it will return false.
Yes,
So three,
Sandeepan.
yeah, because 3 is not equal to 4, so it will return
So,
false.
yeah, so this condition is cannot be the answer.
Yeah.
I mean, this option cannot be the answer. Then
Right.
5 and 2. Will it be same?
No, because 5 and 2 is not same. So this
Yeah,
returns also
the
false.
first condition itself, it will return as false. Then second condition.
Yeah,
I
I
mean,
mean,
the third option.
third option, yeah, it also returns false.
Yes, because 5 and 4 are not equal. The first condition itself, it will give us false. Then here, 5 and 5, 4 and 4, 2 and 2. So this
Yeah.
condition will give me the true as the answer.
Yeah,
Is
and
it
the
clear
other
to
thing,
you?
yeah, and the other thing
Oh,
is that both the lists must have the same number and same equal elements. If they are
equal
different,
number of elements.
yeah, equal number of elements and equal elements as well. Because
Yes.
Well,
if that,
order of the elements should be equal.
Yeah. Same set of elements as well as the order should not change.
exactly. Because if the order gets changed, this always returns false.
Yeah, because you can see this
Second
as an
person.
example, this as an example. Same set of elements, but the order differs. That's why it is not giving the correct answer. Like it's not returning as true. And here is the next question, people. Yeah, I'll just give 3 minutes of time to understand this question and tell me what is the answer. Okay.
It computes the first and last sentence of each of first and last word of each sentence in the given order. I mean, in the same order, actually.
Yeah, correct. So which means to say that A represent the number of sentences in the word.
Okay.
So the list out list will contain another list which is of the first word of the sentence and then last word of the sentence.
Okay. So what are the
So
options
which
are
means to
correct then?
say that
I think D is correct.
Okay.
no,
Others?
A would be correct, man, because A represent the number of sentence in the word. If the it comes to that, no, ma'am, can you please share the screen?
Yeah, sorry, people have stopped sharing by mistake. Yeah, can you see my screen now?
Yeah, the A will be incremented whenever the condition is satisfied. That is, when we reach the word which contains a full stop.
Okay.
So that time only the if condition will be satisfied. So which means to say that for every sentence A will be increased. So A will be incremented by one,
Okay.
added. So which means to say that
Mm-mm.
A represents the number of
Number
sentences
of
in the
words,
word.
number of sentences in the word. Yes, correct. Okay, A option is correct. And
And
someone said D, right? Why the D is correct?
Because if you have, say, two sentences, like, say, sky is blue, full stop, the world is good. I mean,
yeah, D
the,
is correct now. Yes.
yeah. So
Yeah,
what
I'm
does
asking
the,
why the D is correct.
yeah, say, for it, so if you go with the sky is blue, so
Okay.
so in list is empty in the first place and out list are also empty in the first place. So we directly go to if of flag. So because flag is set to true. So flag is set to true. So in list would be x dot word, which is say, let's say sky. And then we set flag to be false. Now, when flag would be set to true, so the flag would
Okay.
only be set to true if and only if the word ends with a full stop.
Yes,
Until then,
correct.
all those things would return false.
Mm-mm-mm.
Because then once it returns false, it cannot be reinitialized to false. Again, it would
Exactly.
reinitialize to true, sorry. It would be reinitialized to false again. And then so as to make it true, you need to reach the end of the sentence.
Yeah.
And
So here,
then,
as
yeah,
you mentioned, here it will just take the first word and then it will become false. So after that, only when the word ends, it will just make it as true. Otherwise, it will remain the false throughout the whole sentence. So in that case, only first word is added so far. And once the word ends, in the in list, that last word is also added here. So the out list contains of a list, I mean like a sublist which containing the first and last word of the each sentence. Because in list is again made as an empty in the 11th line, in the 12th line. Okay. Is that clear to you all people? So here the answer is option A and D. Any doubt?
No.
All right. So moving to the next question. Yeah, so first, this is the code, people. Like, we have to fill the three lines of the code. So this is the question. Just tell me, what did you understand? Like, what can be the possible conditions for the statement one, two, and three? I'll just give you again 3 minutes of time. Just go through it, people.
statement one, we have to check if x dot gender is a key of the dictionary CTD x dot town city.
Okay, so people, have you all just checked the question? Can I show you the options then?
So can you show the option segments?
Yeah.
Yeah. Okay.
It has to be initialized. One thing is it has to be initialized and then added, ma'am. For one thing, 2, 3.
Yeah, go through it, people. No issues. Just take some time also.
As far as my analysis, it's supposed to be option B, ma'am.
Option 2 or 4?
Option B, actually. B.
You mean you're
Because,
referring 2 or 4?
yeah, B,
Because
B.
of the
Option B.
background
B
noise?
for,
B. Yeah. B for
B
boy.
for boy. Yeah, boy.
Okay, okay. Because of the background noise, I'm unable to hear it properly. That's why I asked you to repeat. Yeah, tell me why it is B.
Shall I explain or someone else? Or others will get a chance?
Yeah, that's fine. Others can get a chance. Yeah.
Yeah. So okay. So in the statement one, so we need to check if x dot gender is a key of the dictionary CTD of x dot town city. We need to check because this is a nested dictionary, right? If we
Yes.
So that's what we need to check first, and
Mm-mm.
then all the conditions are satisfied. So then we come to the else block in the 14th line, and
Okay.
we go for we first initialize this city D of x dot town city to be an empty dictionary. Is
Yes. In that, we are just taking the gender and then we are adding the physics mark to that.
Yeah.
Okay. Others, what is the, do you have any other guess for this question?
So in second and third line we are doing because if we don't have that key value pair, we are assigning the key here.
Yes, if the key is not at all present, we have to create a key, right? Like we are trying to create a key value and then we are trying to assign its value as a, like inside we are trying to create a one more dictionary that is gender and then its key value is, its value is physics. So for that we have to create it, right? So here the answer would be B. Do you have any doubt, people? Others? If you want, you can just go through this question and then we can go to the next question. Okay, others, do you have any doubt, no?
No, it's clear. Answer should be B.
Okay, great. All right, people. So here comes the next question. Yeah, just check the question first and then I'll just show you what are the options. Just take
Ma'am,
2 minutes
could you
to read the
please
question.
maximize the screen, ma'am?
I didn't get you, ma'am. Could you
Hello?
please repeat?
Ma'am, could you please, yeah, could you please maximize no, this screen, ma'am?
Yeah,
Because very
sure,
small,
sure.
we couldn't see.
Yeah, yeah, I got it. Okay, I hope the question is visible now, right?
Yeah, yes, ma'am.
Can we see the options? Yeah. Can we see the options at once?
Yeah, sure. These are the options. These are the first two options first. And these are the remaining two options.
Okay, C is anyway wrong. So,
Okay. Because it's mentioned as not of whiskey. Okay.
and B is also wrong, because if word is there as a key in W count, we should increment it by one. Whereas it does it in the fifth step. It should be, so second and fifth line should be swapped.
Hmm. Okay.
Okay.
So A and D are the other options.
Can we go to D at once? Okay. Yes, D is fine.
And this is A option.
Answer D is correct, ma'am. If is key present in the word count, which
A
is a
is wrong.
dictionary,
A is wrong
no,
because W count is getting in initial as dictionary, whereas here it's a dictionary, and you use this member for a list. But the
Yes.
Only D is correct, ma'am. One is,
Exactly, people.
used member, so
Because
option A will not be there. In the second B, else part should be in line number 2 and it should be swapped. So number B is also not correct. Go to the number
mm-mm.
C. If it's not key, so we are in line number 1 itself is not correct. So C will not be there. Only D option left is correct.
Yes. Correct, people. Perfect. So you all understood, right? Like how this dictionary and key things works.
Yeah.
Great. So here is the next question. Yeah, so this is the question. I hope the screen is clearly visible to you all, right?
can you maximize it a bit?
maximize, ma'am.
Yeah. The options actually are not visible. Yeah, now it's fine. First is wrong.
First is correct. There is 4 click. Sir, click of size 3. 1, 2, 3. 1,
There are
2,
three
3.
clicks.
1, 2, 3.
Third is correct, and fourth is also correct. So C and D are correct.
See, maximum size of click that appear in the graph is 3.
Yes, it's correct.
1, 2, 3. But it has not mentioned that, what should be the size.
Yeah, but the maximum size is 3, right? So because you have 0, 11, 6, 0, 12, 6, and 0, 4, 6, the maximum size of this click, all these three clicks are 3, and there isn't any more clicks than that of any maximum number. So that's the maximum size. And a 0, 4 would also be a click of size 2. That's not giving any.
So option C and D are correct, right?
Right. I think so.
Yes, ma'am. Have you all come to the conclusion? Like, what is the answer for this?
C and D. You
C
came
and
to the
D.
conclusion.
Okay. Is that the only answer or?
C and D, I think there are no other possibilities.
Okay, why option A, B, and D are not the answer?
No, I mean C and D are correct. A is not a correct answer because there isn't I mean, they say that there are 4 clicks of size 3 present, but there are only 3 clicks of size 3 present. So one is 111,
Yes.
6, 0, 11,
And
0, 12, 6. I mean, yeah.
yes, only 3 clicks are there. Okay. Option A is not there. Okay. How about option B?
Okay, 0, 11, 6, 12 is not a click.
Okay. And how about option C? Okay. Maximum size of the click is 3.
Yeah. Yeah, maximum is 3. Yeah.
Okay. And option D is of node 0 and 5 form a click of size 2.
Yeah,
Because
that's
they're just,
undirected graph.
yeah. Okay. So everyone got the idea, right? Like for the sixth question.
Yes.
Great. And here is the 7th question, people. Just solve this.
So C is true only if X gener is fiction and X dot language is can be English and non-English both. Then non-English books, yes. So D should be correct.
Okay, others, like what can be the answer then?
Yeah.
Like what option it is?
D is correct.
Yeah, I
Okay,
go with the
then
D.
only one option.
Okay. So it's a multiple select option. So A represents the number of fiction book,
Yes, that's true. Yeah.
Okay,
and B
only two
represent the
options.
represent the number of non-fiction book. But here it should be more clarity non-fiction English book.
Yes.
Then it's more correct. So
Yes.
C is better. D is definitely true, and C is not true.
Okay, so the options
We'll
are
go with the C and D.
okay, good. It's the correct answer as well, people. Actually, here you can see that they have clearly mentioned A is counting only the fiction books, and B is counting the non-fiction only in the English language. And if the number of fiction is greater than the non-fiction English books, then C is true. So these out of these 4 options, only C and D are giving the correct interpretation of. Yeah, and here comes the last question, people. Like, yeah, what is the answer for this?
The first one is wrong because it can be a yeah as
Any
well.
data type.
String as well.
Any data type.
Yeah,
Any data type.
Yeah, exactly. B is not a goal. No, B is also wrong because the values can be repeated.
Yeah, it can be correct.
Okay.
For yes, correct. Third one is correct.
Third is correct. The keys have to be distinct.
Distinct. For that reason only A not is equal to B. Yes.
D is also wrong because the init of DB should have given me 3 and 4 and not 4, 7. That's also wrong.
It should, yes, it should be complete. C
Only
for
option
3
C is
or
correct.
7.
Okay. So which are the options are correct?
C
Only
only.
C,
C.
ma'am.
Only C?
Yes. Yeah, yes, ma'am.
Yes.
Sure.
Great, people. Actually, that is the only option because you can see that for keys A and B in D, A should not be equal to B because there are 2 keys. It has to be a unique one. And then A is always an integer is given in option A. It's not mandatory, right? It can be of any data type, as you people discussed. And here, this is also like, it can be same or it cannot be same. The value can be same for both the keys also. So this is also wrong. And here, D of B has to be the 347. They have asked for init, which is like leaving the last. So it has to be 3, but they have given the wrong option. So only C is the correct one. Okay. So what Z represent at the end of the execution, people? That is the question. So D is a dictionary. Just tell me what the Z represents at the end of the execution.
So number of students from those city X dot town and city whose average marks is less than the average total marks of the set.
Okay, so what can be the answer in this?
Option B.
Option B or D?
It computes, I think it computes the number of students, not number of cities. It computes the
It
number of students here.
count the number of students only. Yes.
Yeah, not
Number of students who are from the cities and who are scored less than the total average mark.
Yes.
yes.
So it has to be like number of students from the cities with the average total mark should, if there is less than the average total marks of that. Okay. So is this question is clear to you all, people?
Because B represents the town or cities. The B variable here.
Yes. Yeah. You can see here, right? Like what they are trying to assign in the D. First, they are just trying to assign the town or a city, inside which they are creating a dictionary, like they are inserting a total, and the total keeps incrementing as well as the count keeps incrementing too. Okay, so for particular total, for particular total, like we are incrementing and particular total also getting included. Okay, if nothing is there, if the city is not present, we are just creating a new one using the else part. At last, we are checking who has scored the less than the average. I hope it's clear to you all, right?
Or we can like create our own custom build.
Okay, and this is the last question for this session, people. Just tell me, what did you understand from this?
Computes the greatest integer, I guess.
There are further 2 more options are there.
Okay. Okay, if we swap the conditions, then the rest and init conditions also get reversed. So in this condition, can you scroll a bit? If first of L is less than L, last of L, then return find something should be rest of L. And the 7 and 10 lines should be swapped.
Yes, correct. So which are the options are correct?
See.
A and B, A and C, sorry.
Okay, others? Is there any other answer is correct or?
No, ma'am. Yes, I think it finds the largest number in the list.
Yes.
The greatest,
And yeah,
largest, maximum.
nothing
Okay.
but here you can see, right? Like if the first one is greater than the last in the sense of it just taking the removing the last, which means it is just trying to find first and last they are comparing. Let's say the numbers are like 12 here and 26, 10 and 19 and 91 is here. Let's say for example. Now 12 and 19 are checked. Is 12 is greater than 91? No. So what they are doing, they are ignoring the smallest element and then they're comparing the rest of elements. 26 or 91? 91 is greater, so ignore it. Now again take. So by this way, they're trying to find only the largest element. If this condition is swapped, which means like if first of L is less than last of L, if they have changed that condition, then the seventh and ninth line also has to be swapped. Then it will give me the same output. So yeah. Do you have any doubt so far, people?
One question in the city,
Okay.
questions will be come from till 12th week or till 11th week.
12th week goes, all the weeks are covered in that.
Because in 12th week is also given in the city.
Yes. Which is nothing but the revision kind thing, right?
Yes, I went through because it is revision kind of thing.
Yeah, so that is also included in that. It's a kind of revision, that's it.
Okay.
Ma'am, just I would like to have the much more understanding about the graph
Mm.
concept, the multiple iterations. Could you just spend 5 more minutes and then
Yeah, sure,
explain
sure.
those?
Yeah, sure, ma. Tell me what
Or
is the doubt.
anything, ma'am. Just any basic concept of graph and iterating through the graph in terms of matrix, or just any concept, ma'am. But I'm not clear about that. Only that. So
Okay, I'll
basically,
just take.
it'll be under week, last 2 weeks of this concept, ma'am.
Okay, let me just take a ninth week. Is that fine? Which includes the basic graph thing, right?
Yeah, yes, ma'am. Yeah.
Okay, do you know what is a click?
Uh, Click, I know that. So every element or node in the graph should be connected to each others.
Hmm. Okay, I hope the screen is visible, right?
Yes, ma'am.
Okay, let's say graph, let's say I'm just drawing it like I'm taking the zeroth vertex here. Okay, it is connected with the first vertex. And let's say 0 is also connected with 2, it is also connected with 3, and it is also connected with 4. So this vertex connection can be either the directed or undirected. So directed in the sense of 0 is connected with 1. Is 1 is connected with 0 then?
No.
Because it's a directed one. So 0 to 1 path is available, but 1 to 0, the path is not available. In that case, we cannot say it's a, like the vice versa path is not available. Let's say I'm giving like the 0 to 2. Now, is path from both the like 0 to 2 and 2 to 0, is both are possible or not?
But in this case, direction is not specified. No arrow mark in this case. What do we consider, ma'am?
Exactly. So we can consider this as a undirected graph, which means it's a double way road. So 0 to 1 is also possible. Sorry, 0 to 2 is also possible. 2 to 0 is also possible. If no direction is mentioned, then it is said to be an undirected graph. So both the ways path is available. Is that clear?
Yeah, yeah, yes, ma'am. Clear.
Okay. So similarly, so this is said to be the vertex. Like you all know, right? Like 0, 1, 2, 3, and 4 are said to be the vertices. And this line is said to be the edges. Okay, like line in the sense of it is connecting two vertices. It is said to be the edge. Is that clear?
Yes, ma'am.
Okay, so click in the sense of, let's say I'm forming something like this. So let's say 2 is connected with 0 is connected with 2, 2 is connected with 5. So by this way, I can say that it forms a click because these are the similar kind. They have some similarities. Based on that, it is connected. So this you can say it as a click. Okay, 0 to 2, 2 to 5. Because 0 and 2 are connected, it's based on some similarity. Then 2 and 5 are connected, it's based on some similarity, which means 0 and 5 form some similarity. So this is what we'll say it as a click, which means there should be some similarities in between. Is that thing clear?
Yes, ma'am.
Okay, so similarly to find the number of edges of a click, this is the formula to find it. Like n into n minus 1 by 2. By this way, we can be able to find number of edges, which means let's take example as n equal to 4. So what will happen? The number of edges should be
6, ma'am. 4 into 3 by 2, so
yes.
6 section.
Which is nothing but I should have a 6 edges to form a click. Like this. Is it clear?
Yes, ma'am.
So 0 is connected with 2, 0 is connected with 3, 0 is connected with 1. 2 is connected with 0, 1 and 3, and 3 is also connected with 0, 2 and 1. So this is what we'll say it as a click. So if you know the number of vertices, by this way you can be able to connect the edges. Like based on the number of edges, you can say whether the whole graph forms a click or not.
So which means, ma'am, I have one more doubt here.
Yes.
Click is based on the similarities they are connected. It is not that every other node should be connected to every other
Yeah,
node.
there is no mandatory like that. If it is a click, then it should be connected. All the node has to be connected with every other node. If there is no similarity, then it doesn't form a click. There can be like this also. Let's say I'm just removing this line. Yeah,
We can
so
say even
now,
this also is a click.
yeah. So in this case, 0, 1 and 2, 0, 1 and 2 forms a click. Because 0 is connected with the other two vertices, 1 is connected with the other two, 2 is connected with the other two. So here in this case, 0, 1 and 2 forms a click out of this whole graph.
0, 1 and 2. Okay, 0,
Nothing but
1,
3 into 2 by 2. So a number of vertices has to be there between these three edges, these two vertices. Only 3. We can count here also. It's 1, 2, and 3. So these 3 forms a click. Is it clear?
Ma'am, 0
no,
can also
but
form
3.
3 is like 0, 1 and 2, 3 vertices. So I am using the
Yeah.
formula as 3 into n minus 1 by 2, which is nothing but 3 into 2 by 2. So I'll get the value as 3 because if I have to consider only these 3, how many edges are there? Ignore this and this because we are not
Yeah. Why
taking
do
3 as a click. If you are considering 3 as a click, then we can consider those edges also.
Okay, it is again based on the consideration, ma'am.
Yes. So let's say I'm trying to consider 1, 2, and 3. Does it form a click?
One. No, there is no connection between the 1 and 2. It won't.
1 and 3. 1 and 2 connection is there. No? 1 and 3 connection is not there. So this doesn't form a click.
Ma'am, 1 and 2 also no connection, right? Direct
How about
connection.
this one? I have
Oh,
connected it
okay.
like
It is
this.
the other. Okay, okay, okay.
Yeah, this is the exact graph. Because I have just drawn this line in between, so I'm just taking like this. Is that clear? Can you able to understand the basics of graph now?
Yes, ma'am.
All right, people. If you have no doubts, you can leave the session. Thank you, everyone.
Okay, thanks, ma'am.
Thank you.